After Pro.
Hi guys, for this next video we will talk about unequal resistors connected in parallel. Just like my last video about equal resistors connected in parallel, the difference is the value of resistance which are not the same. When a number of unequal resistors are connected in parallel to a voltage source, the following conditions prevail. Okay, for number 1. The same voltage E is impressed across all resistors. Where E is equal to V sub R1, equal to V sub R2, equal to V sub R3, and also equal to V sub R4. Then the number 2 condition is that the individual resistor currents are inversely proportional to the respective magnitude. The formula for condition number 2 is Ix over Iy is equal to Ry over Rx. This equation is derived from condition number 1, for example R1 and R2. Since their voltage V sub R1 and V sub R2 are equal, and the formula for voltage is I multiplied by R, it can be written as V sub R1 is equal to V sub R2, since V equals IR. So I1 times R1 is equal to I2 times R2. So I1 over I2 is equal to R2 over R1, which is equal to condition number 2. So meaning, you can set any ratio of the resistor currents. Then number 3 is that the total current for the circuit is I sub T is equal to I sub R1 plus I sub R2 plus I sub R3 plus I sub R4, the summation of all current flowing in each of the resistor. And lastly number 4. The total equivalent resistance of the circuit is the reciprocal of the reciprocal sum of all the resistors, or it can be written as R sub T is equal to 1 over R1, plus 1 over R2, plus 1 over R3, plus 1 over R4, which is derived from the formula R total is equal to E divided I total, where I total is equal to I1 plus I2 plus I3 plus I4, which I is equal to E divided R. So I total is equal to E over R1, plus E over R2, plus E over R3, plus E over R4. Substituting the value of I total to R sub T equals E over I sub T, we will have R total equals E all over E over R1, plus E over R2, plus E over R3, plus E over R4. Then as you can see E will be cancelled out. So R total is equal to 1 all over 1 over R1, plus 1 over R2, plus 1 over R3, plus 1 over R4. Another related conditions to number 4, is that when two equal resistors are connected in parallel, their equivalent resistance is equal to their product, divided by their sum. Or simply R sub xy equals Rx times Ry divided by Rx plus Ry, which is also derived from the R total formula R sub xy equals 1 all over 1 over Rx plus 1 over Ry, and equal to 1 all over Ry plus Rx, all over Rx times Ry. Getting the LCD of 1 over Rx plus 1 over Ry will result to this equation. So as a result, Rxy equals Rx times Ry all over Ry plus Rx. Then lastly guys, it is important to understand that the equivalent resistance of any number of resistors in parallel, of whatever magnitude is always less than the magnitude of the smallest unit. So now we go to the examples guys. Okay, number 1. 3 loads A, B, and C are connected in parallel to a 230 volt source. Load A takes 9.2 kilowatts, load B takes a current of 6 amperes and load C is a resistance of 4.6 ohms. Calculate A. The resistance of loads A and B. B. The total equivalent resistance of the 3 parallel loads. C. The total current. D. The total power. So the given are E is equal to 230 volts. P sub A is equal to 9.2 kilowatts, I sub B is equal to 60 amperes. R sub C is equal to 4.6 ohms. So first we have to solve for R sub A, which is equal to V sub A squared over P sub A, or equal to E squared over P sub A. Substituting the values of E and P sub A from the given, we have 230 volts. squared divided by 9200 watts. The answer will be 5.75 ohms. For R sub B, it is equal to E over I sub A. So we have 230 volts over 60 amperes that will result to 3.83 ohms. The total resistance will be RT equals 1 all over 1 over RA plus 1 over RB plus 1 over RC. Substituting the values RA, RB and RC, we will have RT equals 1 all over 1 over 5.75 ohms plus 1 over 3.83 ohms plus 1 over 4.6 ohms. RT equals 1.53 ohms. So we go now for IT, which is equal to E over RT, so 230 volts divided 1.53 ohms, so the answer will be 150 amperes. Total current can also be solved by summation of its individual currents flowing in each of the resistor. IT equals I sub A plus I sub B plus I sub C. Solving I sub A is equal to P sub A divided by E, so 9200 watts divided 230 volts, which is equal to 40 amperes. Next is to solve for I sub C, which is equal to P sub C divided by E. By substituting the given values, we will have 50 amperes. The answer will be IT is equal to 40 plus 60 plus 50, which is equal to 150 amperes. And lastly, guys, is to solve for its total power P sub T. It is equal to E times I sub T, and by substitution it equal to 230 volts times 150 amperes, so the answer will be 34.5 kilowatts. And we can also solve it by solving the individual power, where P sub T equals 9200 watts plus 230 volts times 60 amperes plus 230 volts squared over 4.6 ohms will also result to 34.5 kilowatts. Then we go now for the number 2 example. A coil of wire having resistance of 3.84 ohms and carrying a current of 0.15 ampere is in parallel with an unknown resistance through which there is a current of 1.44 amperes. Calculate the unknown resistance and total equivalent resistance. Okay, the solution is I1 divided by I2, which is equal to R2 divided R1. The value of I1 is equal to 0.15 ampere. I2 is equal to 1.44 amperes. R1, which is equal to 3.84 ohms, and R2 is the unknown. Substituting the values, we have 0.15 ampere over 1.44 amperes equal to R2 divided by 3.84 ohms. So R2 is equal 3.84 times 0.15 amperes over 1.44 amperes. The answer will be R2 equals 0.4 ohms. For RT equals R1 times R2 all over R1 plus R2. Substituting the given values, we'll have 3.84 times 0.4 divided 3.84 plus 0.4. Then we will have R total is equal to 0.362 ohms. Again, guys, for the summary and solving unequal resistor connected in parallel. Number 1. The same voltage E is impressed across all resistors. Number 2. The individual resistor currents are inversely proportional to their respective magnitude. Number 3. The total current for the circuit is summation of all currents in the branch circuit. Number 4. The total equivalent resistance of the circuit is RT is equal to 1 all over 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. And also remember that when two unequal resistors are connected in parallel, their equivalent resistance is equal to their product divided by their sum. Lastly, the equivalent resistance of any number of resistors in parallel of whatever magnitude is always less than the magnitude of the smallest unit.
Hey guys, thank you for watching. See you on my next vlog. Please don't forget to like, share, and subscribe for more videos.